Okay, perfect. So, now we are going to define a quadratic function. So a function y equals f of x is a quadratic function if, do you guys know what a quadratic function is? Anybody know what a quadratic function is? Okay, that is okay. So a quadratic function is a quadratic function if it has a polynomial function of degree 2. I'm gonna use, maybe that one's better. So what that's gonna look like is just like a squared plus b, or ax squared plus bx plus c equals y or whatever. So that is, so when we have something that's degree 2, it's something that the highest degree is x squared. So what does that graph look like?
Parabola.
Yes, it's a parabola. So perfect. Second answer. The graph of a quadratic function is called a parabola. Awesome. And that looks like, what does a parabola look like? A U. Yep. So it's either open up or down. Okay, so now what we're going to be learning today is putting quadratic functions into standard form. So on your homework on the WebAssign and in the book, they'll call it vertex form, but vertex form is the same as standard form. We just call it standard form. So a quadratic function is in standard form when it is written as, so this is what standard form is going to look like. Oopsie. Plus k. And again, standard form, vertex form, same thing. So this is what we're going to be focusing on today. When you see the graph of something in standard form, again, it's going to be a parabola because it's quadratic. But if the a is positive, it's going to open upward, and if the a is negative, it's going to open downward. So that's just kind of like what it's going to look like if you look at it. So I'll write that off to the side just so you guys know. So if a is greater than 0, opens up, and if a is less than 0, it opens down. Okay. And then also when you're looking at the graph, do you have a question?
How does that look like?
What does it look like? Okay, so here, I'll erase this. All right, so we have our graph. Oh, that's kind of bad. So if our a, your first thing, is less than 0, it's going to look like that. And then, so your arrow, or the end of your graph is going to be pointing down. And then, if a is greater than 0, your graph's going to look like that. Does that make sense? Okay, perfect. All right. And then, when you're finding your coordinates of the vertex, so your vertex is going to be your point, it's going to be like a max or min, which we'll talk about later, but it's where your two curves like meet at the tip. So that's what your vertex is. And the point of your vertex when you're looking in standard form is going to be h, comma, oh, whoopsie, put my hand on it, h, comma, k. So that is going to be your vertex. All right, now, for the first example, we're just going to find our vertex. So what do you guys think the vertex is here? It's going to be a point, h, comma, k. If you look at our, here, I'll write this up here. So when you're looking at your vertex, yep, do you have an answer or question?
An answer. 3, -2.
Okay, yes. So I'm glad you said that. It's not 3, it's actually -3. But you're correct. So it's -3, 2. Why is it -3, not +3?
Because the formula has a negative, so when it's a positive, it's shouldn't be negative.
Yep. So in our formula right here, since the h is negative, it's really going to be the opposite. Because technically the -3, when you put it in there, you put -3 in here, it makes it positive, right? So that's why it's -3 instead of +3.
But then why is it a +2?
Oh, sorry. Yes, it is -2. My bad. Oh, that was kind of bad. -3, -2. Okay. And then is this parabola going to open up or down?
Upwards there.
Yep. Yep. So we're going to open up since this 2 right here is positive. Touching the thing. All right. Okay, how does everyone feel about vertex? Good? Okay, the biggest thing is you're going to have to memorize this formula right here, okay? If you know that, you'll be okay. All right. Now, we are going to work on taking a quadratic function and putting that into standard form. So, the process used to write a quadratic function in standard form is called completing the square. Okay, so now, thumbs up or thumbs down, who remembers ever completing the square? Maybe in a previous math class you had, maybe you don't remember what completing the square is, which is totally fine. Anybody? Thumbs up, thumbs down. Okay, cool, maybe, kind of not. All right, so, well, I'll teach you, so you don't need to worry about it. All right, so, here we have our quadratic function. We're going to complete the square to get it into standard form. So, and then we're going to find the vertex. So the first thing that we're going to kind of do is we're going to just take the x's. So we're going to split it up. So I'm just going to throw parentheses around that because that's all we want to focus on right now. Okay? So then what we'll do is complete the square. So here, can I change the color? I'll change the color. We'll do blue. So when we complete the square, we're basically adding on terms to help us get it into standard form. So completing the square, you're going to take whatever coefficient is on the x, which in this case is 6. You're going to half it, and then you're going to square it. Oh, whoopsie. And then square it. And then you're going to add it on to that little part that we just took out, but then we're also going to subtract it off the end. So I'll show you what that's going to look like here. So we have f of x equals, oh wait, first thing actually that you have to do, sorry I forgot, you have to take out whatever coefficients are the same. So in your x squared plus 6x, what coefficient can you take out? Well, actually you're going to keep the x's, sorry. Just the coefficient, just the whole number. Yep, there's none, so we'll just take out 1. Just so we can have a like in our formula. Since there wasn't one, I forgot. But yep. So that's what we'll have. So then, when we half our 6 and square it, what do you get? Yes, I think somebody said it, 9. So, what we're going to do is we're going to add that 9 on right there. And then since we added a 9, it really would change our original function. So what we have to do is we also have to subtract 9 times 1. So since we have that 1 that we took out, you have to multiply by the 9 because technically you're multiplying that 1 in to every single like number you have there. So if we had to take out like a 2, you would multiply by a 2 at the end. Okay, so that is kind of what completing the square looks like in this case. Now we are going to simplify this a little bit. So what can these parentheses that we have right here, the quadratic, what can you simplify this to be? X plus 3 squared. Is that what you said? Perfect. Yep. So you can make that x plus 3 squared. Man, I keep putting my hand up. So that becomes x plus 3 squared. So in this, like since we're completing the square, you're going to end up getting a squared every single time. So every single time you do this, you're going to get a squared. So then we still have that plus 5 minus 9 times 1. So then we'll continue and we get x plus 3 squared plus, what do you guys get for that? Or actually it's,
-4.
yep, it's actually minus 4. Minus. Keep touching it.
1 second.
Yes.
How did we get to x plus 3 squared?
So when you take, sorry, I should have explained that. So when you take x squared plus 6x plus 9, we're just factoring this. So you're seeing what multiplies to 9. Yep, what multiplies to 9 adds to 6. So you get x plus 3, x plus 3. And again, every single time you do this, it's going to be, you're going to get something squared. So it's going to be the same number. So if you just look at that middle term, it's just going to be like half of that. Or if you look at this last term, it's going to be the square root of that. Okay, so actually, now we're going to find the vertex. So we have it in our standard form now. So we went from quadratic to standard, and then let's find the vertex. So what do you guys think the vertex is? Remember, it's h comma k.
-3, -4.
Yep, -3, -4. Okay. How does everybody feel about completing the square? We've done one problem, but give me a 1 through 5 on your fingers, how confident you are. Okay, cool. All right, so the next one, we have another completing the square. What I'm going to do is I'm going to have you guys work on this one on your own. Again, work with the people next to you, talk to them, work through it together. Now for this one, since you do have coefficients right here, you can take out a -3 in the beginning. So instead of taking out like a 1, how we did in the last problem, you're going to take out a -3. So that's kind of how you're going to start. So go ahead and work on that for a little bit. And then if you have time to, you can find the vertex. So that was from completing the square. So we took half of 6 and then squared it. So half of 6 is 3 squared is 9. So that's where we got the 9. And then remember, you have to subtract it off of that too, since you added it. Yep. Yep. Yeah, so you'll subtract off 16 and then times -3 since you took -10, like multiplying -3 times 16. Just to subtract that off since you added.
Jesus Christ. That can't be right.
Yep.
After you get that 1 second. Fine. What am I doing?
So Negative 37, it'll be minus 16 times negative 3. So that'll be positive.
Positive 16?
Well, since you're taking negative 16 times negative 3,
Mhm.
it would be using.
Okay, so I do those two first and then I do that.
Yes.
Okay,
Yep.
thank you.
Yep. It'd be positive 4. Did they get 63? No. Why do I have 63 here? So this will be a, this should be a subtraction. No. So the reason why you're subtracting it here is because you're adding it here, so you have to like counter it. Okay. Because if you just added 16, that would change the function. Okay. So you like add it and then also subtract it. Okay. Oh, that's what we did up here. What? That's what we did in the. What? No, I got. No, I got. Cool. 159.
Did you fill the vertex? No.
Do you need help?
Did you? I did something.
37.
You have to take the 3 out of both of those.
Oh, yep. Yep. Yes.
Then you have.
And then you have to multiply that by negative 3. It should be
That's a lot.
negative 3.
I mean, no, I love that.
Yep.
All right, are you guys ready to go over it? Yep. We can just go over it for how much you guys have so far. And then I'll be out. Okay, so like I said, first thing we're gonna do, we're gonna just look at these terms, and we're taking out the coefficient. So we'll take out negative 3, and then we're left with x squared plus 8. It's negative plus 8x minus 37. Okay, next step. What'd you guys do? Yes, yep, half and square the 8. So then we get negative 3x squared plus 8x. What'd you get for that?
16.
Yep.
16.
Plus 16. And then what do we do?
Minus 16.
Yep. Does everybody understand why we're doing, oh wait, that's negative. Why we're doing the negative 16 times negative 3? It's okay if you don't. I can explain it. Okay, perfect. So let me get a different color up here. So the reason why we're doing this is because here we're adding a 16 and really you're multiplying it by 3. And when you do that, you kind of have to counter it because you can't just add 16 to a function and expect it to be the same function. So since we're adding 16 and multiplying it by 3 in that first half, you have to subtract it at the end. So really we're just like adding the subtraction on at the end so that way it's still the same function. Okay. Then where do you go from here? Yep, you can factor the thing. So what did you guys get when you factored it?
X plus 4 squared.
Yes. X plus 4 squared, and then we have our minus 37 minus 16 times negative 3.
Negative 16 times negative 3. Which gives you 48. So you can simplify the outside.
Yep. So we can simplify that last part that we just have. And what did you guys get? Yep. Plus 11. So we just did that negative 16 times negative 3 and then minus 37. Okay. Does everyone understand how we got to that standard form? Okay. Perfect. Now, what did you guys get for the vertex?
Negative 411.
Yes. So our vertex is negative 4, 11. Because that 4 on the inside is positive, really, it's negative because we subtracted a negative. So we get negative 4, 11 for our vertex. All right, so that was the last one on that. But, okay, so you have homework, a web assign due Sunday night, and you're going to have problems like this on the web assign. But the web assign is going to have you put it in standard form. It's going to call it vertex form though, but no, it's standard form. And then it's going to have you find the x and y intercepts. You guys remembered how to find x and y intercepts? Okay, maybe. So when you're finding the x-intercept, you're trying to find where the graph is crossing your x-axis. So you're going to plug in 0 for y. And then when you're finding your y-intercept, you're trying to find where the graph is crossing the y-axis. So you're going to plug in 0 for x. So when you do that on your homework, no, that's how you do that. And then it's going to have you graph it. There's a way to graph in WebAssign. There's also like a parabola function. When you do the parabola function, you just want to hit the vertex first, and then you could hit another point. And the points that you're going to want to use to graph is going to be your x and y intercept and then your vertex. So you can use those 3 points, and then you'll just make your parabola. And then it'll ask for domain and range. So when you have a graph, what's your domain? What values?
The x values.
Yep, your domain is your x values. Your range is your y values. All right. So that's just a little. Yes.
What would you be plugging in the zeros for to find the values?
Oh, yes. Great question. So when you're doing your x and y intercepts, you can plug it into your the standard form that you found. So like here you could just plug in 0 for y, and then you solve for x to find your x intercept. Yep.
In for the inside bit?
Yep.
Okay.
Mm-hmm.
Got it. Thank
you. Yep. All right. Now we are going to move on to our finding maximum and minimum values of a quadratic function. So the maximum or minimum value of a quadratic function always occurs at x equals h. And then the value is always k. So the value, looking at our graphs, when we have a is less than 0, is it going to be a max or a min? At our vertex. Max, yep. And then when we have a is greater than 0, our vertex is down here, so then it's a minimum value. So, write that. So it's maximum if a is less than 0, minimum if a is greater than 0. Okay, and then now what we're really going to be working on is going to be finding a max and min for a quadratic function. So when we're looking at just our regular quadratic functions, not the standard form, we can find a maximum or minimum value that occurs. It's going to occur at x equals negative b over 2a. And then the value is f of the negative b over 2a. So important words, is this a perfect highlighter? So important words I want to highlight here. This is where the value occurs, and this is the value. So when we go to the next problems, they're going to be some word problems, but it's going to be okay. You really want to pay attention to where it's asking you where it's occurring at, and then what the actual value is. So really your f of negative b over 2a, that's going to be like your y value. So when you plug in where the value occurs, then you'll find the real value. All right. Now we will do an example. So, the number M of mountain bike owners in millions in the United States from 1983 to 1990 can be modeled by M equals 0.337 t squared minus 2.265 t plus 3.962, where t equals 3 represents 1983, and what year was the number of mountain bikes a minimum? So, if we look here, it tells us that t equals 3 represents 1983. So we know that t is what our years is going to be. And the question asks us, in what year? So we're really just trying to find, I'll go back up here. Really what we're just trying to find is this right here for this problem. We don't need to plug it in. So we're just finding what our x is. All right. So we have our formula. So we're just using t in this case instead of x. So we have t equals b over 2a. Okay. Do you guys know what your a and your b is? Do you know like what that means? All right. So your a is going to be this coefficient right here, and your b is going to be this coefficient right here. So your a is where it's like your t squared, and then b is where it's t. So even if your function is like in a different order, your t squared is going to be your a still. T is just going to be b. So then we'll just plug those values in. So we get t equals I'm just going to leave it right there. The opposite of negative 2.265 over 2 times 0.337. Okay. So if you guys want to plug that into like a calculator. Do you have a question?
Would the top still be negative if the b is already negative?
So yeah, you could just make it positive.
Okay.
I just left it there. But yeah, it would become positive.
So we don't use the squared from the. Like we just
Nope.
use the coefficient.
Yep, we're just using the coefficient here. Don't have to worry about the t squared or anything. So what do you? Yep.
Where should we round?
I just rounded to the third since it's since all the other numbers in the problem was like that. So when you guys plug that in to your calculator, what do you get?
3.361 million.
Yep. So we get 3.361. So yep, I just rounded it to the third decimal. And then the question's asking us, in what year was the number of mountain bikes a minimum? So this t right here, again, is giving us year. So in our real answer, what is going to be the year where it's a minimum? If we see here, t represents 1983. So if you're like, we're looking at like 1983 and some change. So we're still going to be in 1983. So the mountain bikes were a minimum in 1983. All right. I'll talk through kind of the beginning of this, but then I'm going to give you a review sheet over this, but I'll kind of just explain, but we won't go through the whole problem. So for this problem, we have the number of bacteria in a refrigerated food. So the number of bacteria is going to be this. And then right here, you can see it says your T is representing your temperature of the food in Celsius. And then your question is asking, let's use this one or this one actually. So your question is asking you at what temperature. So what are you looking for when it's asking for the temperature?
T.
Yep, T. So just all you have to find is your T equals negative B over 2A. That's what you're finding. Exactly what we did in the problem, the last problem. But then it asks, will the number of bacteria be minimal? And then it says, what is the minimum number of bacteria? So again, going back up to where we were defining it, when it's asking for the minimum number, that is asking for the value. So that means you have to take what you found for your T equals negative B over 2A. You have to take that, plug it in, so you do n of, and then negative b over 2a. So you plug in whatever you found for that into this, and that'll give you your minimum number of bacteria. So that's that value again. Okay, so, yep, we have about 7 minutes left. So Dr. Joe will go over that. I have a review sheet. It has one of each problem. Don't worry about finishing it, and I'm not going to grade it, but when class is over, I'll have you hand in whatever you have done, just to gauge kind of like how much you guys understand. Okay. So again, if you have any questions, I'm happy to help. And yeah. Remember, you have quiz Friday. Come to office hours. Go see Dr. Joe. Go to the math center. And you have a web assigned due tomorrow night. And I can post the answers to this, or have Dr. Joe post them on Moodle, or I can email them to you or something. Yeah, again, not for a grade. I'm just trying to see where you guys kind of are at.